Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Kita sambung lagi dalam video seterusnya, iaitu berkenaan dengan applications of differentiations. So, kali ini kita nak bincangkan berkenaan dengan optimum value problem. So, basically optimum value problem, so kita akan gunakan first derivative dan juga second derivative test untuk kita selesaikan masalah yang berkenaan dengan optimum value problem. Baik, kita fokus dengan first point dahulu, iaitu okay. So let's say that we have a function y equals to fx, and this y is equals to fx has a maximum and minimum value at x is equals to c. Okay, x is equals to c, where it is first derivative f prime c is equals to 0. So therefore we can say that we were going to have a maximum point. Okay, kalau kita tengok maximum point for f prime c is equals to 0 if our double prime f c is less than 0. Okay, dan kita akan kata we are going to have a minimum point at c if we have f double prime c is greater than 0. Okay, so ini adalah merupakan konsep asas kepada optimum value yang kita akan guna pakai untuk selesaikan problem yang melibatkan optimum value problem. Baik, untuk selesaikan problem yang melibatkan optimum, saya ada sediakan beberapa steps dekat sini. So kita akan ikut exactly steps yang ada dekat sini. So the first step untuk kita selesaikan optimum value problem is, the first one is kita nak kena identify. Okay, so kita nak kena identify the variable that to be maximized. Contohnya dekat sini katakan y, variable yang kita nak maximize tersebut. So kita kena identify whether it is x or whether it is y. Then after we identify, we straight away express y in terms of a single function. Okay, tengok dekat sini ya. So kita akan express y into a single function. Okay, so this is the second step. Okay, so let's say that here we have y is equals to fx, and then 3, we're going to solve for f prime x is equals to 0, ataupun dekat sini kita boleh katakan y prime is equals to 0 if we use y, ataupun kalau kita guna fx, kita akan tulis f double prime x equals to 0. And then step yang keempat, we are going to verify the types of solution of f prime x equals to 0 with using second derivative test, whether it is maximum or minimum. And lastly, nombor 5, kita akan tengok kita akan dapatkan the optimum value of y fx if it is required. Okay, so 5 step ni kita akan gunakan accordingly untuk kita selesaikan problem yang melibatkan optimizing problem. Okay, baik, kita pergi kepada contoh yang pertama. Okay, contoh yang pertama, example 1. A rectangular region is formed by a 16 cm string. Okay, 16 cm string. So parameter of rectangular adalah 16 cm. Find the length A and the width B of the region if the area of the region is to be maximum. Okay, so first saya akan draw rectangular dahulu untuk illustrate this problem. Okay, kalau merah, kalau biru. Right. So so we know that our length is A. So this is our length. Okay, which is equals to A, and we have our width of rectangular, which is B. And we know that parameter, and the second information that we have is parameter of a rectangular is 16 cm. Alright, so first we're going to start with the first step yang kita bincang tadi, the first steps. Okay, which is we are going to identify the variable that needs to be kita nak kena identify the variable to be maximized. Okay, so since we are talking about area, okay, area that need to be maximum, okay, so bermaksud dekat sini variable yang kita nak, okay, ataupun kita nak identify dekat sini adalah area of the rectangular. So saya akan let y is equals to area of rectangular. Okay, so means that we know that the formula of area of rectangular is a times b, so therefore y is equals to ab. Okay, so this is actually the variable. Okay, the variable y is in terms of ab. Okay, variable that need to be executed identify, which is y. The second step is we are going to express y, sorry, we are going to express y into a single variable. Okay, as we notice here, now we have y is equals to ab. Kita ada dua variable, so now kita nak jadikan dia satu variable saja. So in order to do that, so we're going to use the informations of parameter of the rectangular here. So we know that our parameter of rectangular is 16 cm. Okay, so the formula of rectangular is, we know that it is 2a plus 2b, which is equals to 16. Then kita akan factorize 2. Kita dapat a tambah b sama dengan 16. Okay, bahagi 2 for both side. So kita akan dapat a plus b is equals to 8. Then saya akan simplify. A is equals to 8 minus with b. So dekat sini kita akan gunakan a is equals to 8 minus b untuk kita express untuk kita masukkan dalam y, iaitu a, b. Okay, now we substitute, okay, so we substitute a is equals to 8 minus b into y untuk kita jadikan dia single variable. Then kita akan dapat y is equals to 8 minus with b times b. Then kita simplify, expanding, kita akan dapat 8b minus b squared. So now kita dah jadikan dia dalam a single variable. Okay, so langkah yang ketiga, di mana kita nak kena solve for y prime is equals to 0. Okay, so kita nak kena solve y prime is equals to 0. So we know that our y prime dekat sini adalah 8 minus with 2b, which is equals to 0. Then simplify, try to solve. Therefore we get b is equals to 4. So this b is equals to 4. Okay, so this b is equals to 4. Okay, okay, nilai b is equals to 4. Dan kita nak kena dapatkan the fourth one. Okay, step yang keempat, kita nak kena identify. Okay, identify ataupun verify. Okay, verify the type, the type of solution. Okay, using second derivative. Okay, using second derivative. Okay, then so identify using second derivative. So kita nak kena dapatkan y double prime. So we are going to have minus 2. So this is actually less than 0. So therefore we can say that at so the area of rectangular is maximum when B is equals to 4. Okay. And lastly, kita nak dapatkan, okay, so lastly kita nak dapatkan nilai, kita nak dapatkan nilai nilai A. So since we have B is equals to 4, okay, so we have a formula of A equals to 8 minus B. So kita substitutekan B dalam A, dalam formula ni. Then kita akan dapat A is equals to 8 minus with 4. Therefore kita akan dapat A is equals to 4. Then we can say that the length and width of the region is 4 cm respectively, so that the area of the region is a maximum. Okay, alright. So kita sambung example seterusnya, okay, which is example 2. Okay, so the figure below shows a cone with a circular base of radius r, and the height of the cone is h. Given that the length of AB is 3 cm, and find the values of r and h if the volume of the cone is to be maximized. Okay, so kita nak dapatkan nilai r dan h if the volume is to be maximized, and lastly kita nak determine the maximum volume. So seperti biasa kita akan ikut step yang kita dah bincang sebelum ni. Kita ada 5 steps, so we're going to follow the steps accordingly. So the first one is we are going to identify the variable. Okay, so since we are talking about volume that need to be maximized, so definitely the variable that we're looking for here is actually V. So let V is equals to volume of the cone. Therefore volume of V is actually 1/3 pi r squared h. So this is actually the formula of cone. Okay, and so we'll continue with the second step, which is we are going to express y into single variable. Okay, kita nak jadikan dia single variable. So in this case kita nak V dekat sini, sorry, express V into a single variable. So we notice that in the formula of volume V here, kita ada dua variable, iaitu R dan juga H. So kita nak jadikan adalah single variable. Since we are talking about optimizing of the volume, so apa yang kita nak tengok dekat sini adalah perubahan ketinggian. Okay, so ketinggian. So therefore, so I'm going to simplify of the equations from the Pythagoras theorem. Kalau kita tengok dekat sini, we have a right angle triangle, whereby kita akan dapat Pythagoras theorem 3 squared is equals to r squared plus with h squared. And I'm going to simplify r squared equals to 3 squared minus h squared. Saya akan simplify r in terms of, disebabkan saya nak simplify volume V in terms of h. Okay, so therefore our r saya punya r squared dekat sini dia akan jadi 9 tolak dengan h squared. So I'm going to use this one, substitute dalam V dan jadikan dia in terms of h. So okay, so kita akan substitute R squared is equals to 9 minus with H squared into V. So kita akan dapat V is equals to 1 over 3 pi 9 minus H squared times with H. So saya simplify, darabkan, expand. Saya akan dapat 1/3 pi 9H tolak H kuasa 3. Alright, now I already expressed in terms of H, only a single variable. Okay, then the third one, we are going to solve for dVdH is equals to 0. Okay, so dVdH is equals to 0. Then saya akan differentiate V with respect to H, which is equals to 1/3 pi ni constant, kita keluarkan daripada proses derivative. Okay, 1/3 pi. So bila saya differentiate 9H, saya akan dapat 9. Bila saya differentiate H kuasa 3, saya akan dapat 3H kuasa 2. Alright, so this is actually for my derivative, which is equals to 0. And kita nak selesaikan ni, so by cross multiply, saya akan dapat 9 minus 3H squared equals to 0. Then minus 3H squared equals to minus 9. Dividing minus 3 for both side, saya dapat H squared equals to 3. Then H is equals to plus minus 3. So noted that H ni adalah merupakan ketinggian cone. So kita bercakap tentang distance dekat sini, panjang ataupun panjang tinggi sesebuah cone. So dalam kes ketinggian, kita akan mengambil nilai positif sahaja instead of negative. So therefore dekat sini saya akan pilih H is equals to 3 as a solution for H. Alright, then yang keempat, kita nak verify the solution. Okay, verify the solutions of H dekat sini, sama ada dia maximize or minimize dengan menggunakan second derivative. Okay, second derivative. So saya akan lakukan second derivative, which is d squared V over dH squared. Okay, so lagi sekali saya akan differentiate yang ni. So 1/3 pi is a constant. Lagi sekali, bila saya differentiate 9 becomes 0. Then I got minus 6H. Okay, nah, minus 6H. Bila simplify, sini bersamaan dengan 2. Then saya akan dapat minus 2 pi H. So since I have the value of H, which is 3 dekat sini, okay, which is H is equals to 3, so saya boleh substitute masuk dalam d squared V over dH squared ataupun second derivative. So saya akan dapat minus 2 3 pi, which is this value is actually less than 0. So we can say that since it is less than 0, we can say that the volume, okay, the volume of the cone is a maximum. Okay, it's a maximum when H is equals to 3. Okay. Okay, now we are going to solve ataupun kita nak cari volume for maximum. Okay, so before that we need to find the value of R dengan menggunakan formula R squared is equals to 9 minus with H squared. So we know that our H is actually equals to 3. Then kita substitute masuk dalam R squared is equals to 9 minus 3 squared. Okay, then it's become 9 minus with 3, which is equals to 6. Therefore R is equals to 6. Alright, okay, 6. So remember again, kita tak ambil nilai negatif dia disebabkan oleh distance tadi. So therefore a volume of maximum, which is the formula, is 1 over 3 pi R squared H. So kita akan masukkan nilai accordingly. So our R is actually 6 squared times with 3. Okay, then this one will be simplified. Okay, which is 2. then kita akan dapat 2 sec 3 pi cn cube as the volume of maximum of the cone. Right. Okay.